Chapter 15.9 2.87.1 of the NFPA 101 Life Safety Code addresses emergency lighting within tunnels, whether enclosed or unenclosed. It mandates that emergency lighting shall be provided within all tunnels. The code stipulates that the emergency lighting fixture shall be acceptable for use in such a location. This means the fixtures must be rated for the environmental conditions present in the tunnel. Consider factors like moisture, temperature, and potential physical damage. Firstly, determine if the tunnel is considered a wet or damp location. This classification will dictate the required enclosure type for the lighting fixtures. Secondly, assess the ambient temperature within the tunnel. Select fixtures rated for the maximum expected temperature to prevent premature failure. Thirdly, evaluate the potential for physical damage to the fixtures. If the tunnel is subject to impacts or vandalism, choose fixtures with robust construction and protective guards. Fourthly, review local electrical codes and regulations, as they may have additional requirements for tunnel lighting. Fifthly, ensure that the selected fixtures meet all applicable safety standards and are listed by a recognized testing laboratory. Sixthly, consider the light output and distribution of the fixtures to provide adequate illumination throughout the tunnel. Seventhly, incorporate energy-efficient lighting technologies such as light-emitting diodes to minimize operating costs. Eighthly, design the lighting system to provide uniform illumination and avoid shadows or glare. Ninthly, install emergency lighting fixtures on a separate circuit with battery backup to ensure operation during power outages. Tenthly, regularly inspect and maintain the lighting system to ensure its continued functionality and compliance. In selecting lighting fixtures for a tunnel environment, several key factors must be taken into account to ensure safety, compliance, and optimal performance. These considerations encompass environmental conditions, fixture ratings, lighting design, and regulatory requirements. Let's delve into each aspect in detail. Firstly, assess the environmental conditions within the tunnel. Tunnels often experience high humidity levels due to groundwater seepage or condensation. In such cases, it is crucial to select lighting fixtures that are specifically rated for wet or damp locations. These fixtures are designed with sealed enclosures to prevent moisture from entering and damaging the internal components. The ingress protection, or IP, rating is a standardized measure of a fixture's resistance to dust and water. For wet locations, fixtures with an IP rating of 65 or higher are recommended, indicating protection against water jets. Damp locations may require fixtures with an IP rating of 44 or higher, providing protection against splashing water. Secondly, consider the ambient temperature within the tunnel. Tunnels can experience significant temperature variations depending on their depth, ventilation, and geographic location. High temperatures can degrade the performance and lifespan of lighting fixtures, while low temperatures can affect their starting characteristics. It is essential to select fixtures that are rated for the expected temperature range within the tunnel. The operating temperature range is typically specified by the manufacturer and should be carefully reviewed before making a selection. For high-temperature environments, fixtures with heat-resistant components and adequate ventilation are recommended. Low-temperature environments may require fixtures with special ballasts or drivers that are designed to operate reliably at cold temperatures. Thirdly, evaluate the potential for physical damage to the lighting fixtures. Tunnels can be subject to impacts from vehicles, equipment, or falling debris. Vandalism is also a concern in some tunnels. To protect the fixtures from damage, it is advisable to choose fixtures with robust construction and protective guards. The housing material should be durable and resistant to impact. Polycarbonate and aluminum are commonly used materials for tunnel lighting fixtures due to their strength and corrosion resistance. Protective guards, such as wire mesh or polycarbonate covers, can be installed over the fixtures to prevent damage from accidental impacts or vandalism. Fourthly, ensure that the lighting fixtures meet all applicable safety standards and are listed by a recognized testing laboratory. Underwriters Laboratories, or UL, and Canadian Standards Association, or CSA, are two commonly recognized testing laboratories that certify electrical products for safety. Look for the UL or CSA listing mark on the fixture to ensure that it has been tested and found to comply with applicable safety standards. These standards cover a wide range of safety aspects, including electrical shock protection, fire resistance, and material safety. Compliance with these standards is essential to ensure the safety of personnel and the integrity of the electrical system. Fifthly, consider the light output and distribution of the lighting fixtures. The level of illumination required in a tunnel depends on several factors, including the tunnel's length, width, traffic volume, and ambient light levels. The Illuminating Engineering Society, or WISE, provides recommended illumination levels for various applications, including tunnels. The light output of a fixture is measured in lumens, which is a measure of the total amount of light emitted by the fixture. The light distribution is the way in which the light is spread out from the fixture. A well-designed lighting system will provide uniform illumination throughout the tunnel, minimizing shadows and glare. Sixthly, incorporate energy-efficient lighting technologies such as light-emitting diodes, or LEDs, to minimize operating costs. LED are significantly more energy efficient than traditional lighting technologies such as incandescent and fluorescent lamps. LED also have a much longer lifespan, reducing the need for frequent replacements. This can result in significant cost savings over the lifetime of the lighting system. In addition to energy savings, LED also offer other benefits, such as instant on/off switching, dimming capabilities, and improved color rendering. Seventhly, design the lighting system to provide uniform illumination and avoid shadows or glare. Uneven illumination can create visual distractions and make it difficult for drivers or pedestrians to see clearly. Shadows can obscure obstacles or hazards, increasing the risk of accidents. Glare can cause discomfort and reduce visibility, especially for drivers at night. To minimize shadows and glare, it is important to carefully position the lighting fixtures and select fixtures with appropriate light distribution patterns. Fixtures with wide beam angles can provide more uniform illumination. Glare can be reduced by using fixtures with diffusers or lenses that soften the light. Eighthly, install emergency lighting fixtures on a separate circuit with battery backup to ensure operation during power outages. Emergency lighting is essential for ensuring the safety of personnel in the event of a power outage. Emergency lighting fixtures should be powered by a separate circuit from the normal lighting system. This circuit should be connected to a battery backup system that can provide power to the emergency lights for a specified period of time, typically 90 minutes or more. The battery backup system should be automatically activated in the event of a power outage. Ninthly, regularly inspect and maintain the lighting system to ensure its continued functionality and compliance. Regular inspection should be conducted to identify any damaged or malfunctioning fixtures. Burnt-out lamps or faulty ballast should be replaced promptly. The fixtures should also be cleaned regularly to remove dust and debris that can reduce their light output. A preventative maintenance program can help to ensure the long-term reliability and performance of the lighting system. Tenthly, consider the aesthetics of the lighting fixtures. While functionality and safety are the primary considerations, the aesthetics of the lighting fixtures can also play a role in the overall design of the tunnel. Fixtures that are visually appealing can enhance the tunnel's appearance and create a more pleasant environment for users. Choose fixtures that complement the tunnel's architecture and design. By carefully considering these factors, you can select lighting fixtures that will provide safe, efficient, and reliable illumination for the tunnel environment. Remember to consult with a qualified electrical engineer or lighting designer to ensure that the lighting system meets all applicable codes and standards. This professional can also assist with the design and installation of the lighting system. Furthermore, the Life Safety Code, particularly Section 7.9, addresses specific requirements for emergency lighting. This section emphasizes the importance of providing adequate illumination to allow for safe egress from a building or space during an emergency. It specifies minimum illumination levels, uniformity ratios, and backup power requirements for emergency lighting systems. When selecting lighting fixtures for a tunnel, it is crucial to ensure that they meet the requirements of Section 7.9 of the Life Safety Code. This includes selecting fixtures that provide sufficient illumination to allow for safe egress, as well as ensuring that the fixtures are powered by a reliable backup power source. The backup power source should be capable of providing power to the emergency lights for a minimum of 90 minutes, as required by the Life Safety Code. In addition to the Life Safety Code, other codes and standards may also apply to tunnel lighting. These may include the National Electrical Code, or NEC, which provides requirements for the installation of electrical systems, and local building codes, which may have additional requirements for lighting. It is important to consult with a qualified electrical engineer or code official to ensure that the lighting system complies with all applicable codes and standards. Lighting control systems can also be used to enhance the energy efficiency and functionality of tunnel lighting. These systems can automatically adjust the light levels based on occupancy, time of day, or ambient light levels. For example, the light levels can be dimmed during periods of low occupancy or when there is sufficient daylight available. Lighting control systems can also be used to monitor the performance of the lighting system and provide alerts when maintenance is required. The National Electrical Code, specifically Article 500 and related articles, addresses hazardous locations. While the tunnel itself might not inherently be classified as a hazardous location, certain conditions could warrant such a classification. For example, if flammable gases or vapors are present due to the proximity of fuel storage or industrial processes, then portions of the tunnel could be classified as Class 1, Division 1 or 2 locations. In such cases, lighting fixtures used in those areas must be specifically designed and certified for use in hazardous locations. These fixtures are designed to prevent the ignition of flammable substances. They typically have explosion-proof enclosures and are constructed of materials that are resistant to corrosion and other environmental factors. The selection of lighting fixtures for hazardous locations requires careful consideration of the specific hazards present and the applicable codes and standards. The lighting levels should be adequate for the tasks performed in the tunnel. Insufficient lighting can create safety hazards and reduce productivity. The lighting should also be uniform to avoid shadows and glare. Shadows can obscure obstacles and create trip hazards, while glare can cause eye strain and fatigue. The lighting system should be designed to minimize shadows and glare and provide uniform illumination throughout the tunnel. The color rendering index, or CRI, of the lighting fixtures should also be considered. The CRI is a measure of how accurately a light source renders colors. A high CRI value indicates that the light source renders colors accurately, while a low CRI value indicates that the light source distorts colors. For applications where color discrimination is important, such as inspection tasks, lighting fixtures with a high CRI value should be used. The maintenance of tunnel lighting is essential to ensure its continued performance and safety. The lighting fixtures should be inspected regularly for damage or malfunction. Burnt-out lamps should be replaced promptly, and the fixtures should be cleaned to remove dust and debris. The electrical system should also be inspected regularly to ensure that it is in good working order. A preventative maintenance program can help to extend the life of the lighting system and prevent costly repairs. The cost of tunnel lighting can vary depending on several factors, including the type of fixtures used, the size of the tunnel, and the complexity of the lighting system. LED lighting fixtures typically have a higher initial cost than traditional lighting fixtures, but they offer significant energy savings over their lifespan. A well-designed and maintained lighting system can provide a safe, efficient, and aesthetically pleasing environment for tunnel users. Emergency lighting in tunnels serves a critical role in ensuring the safety of individuals during power outages or other emergency situations. These systems are designed to provide illumination that allows people to safely evacuate the tunnel or navigate to a safe area until normal power is restored. The design and installation of emergency lighting systems in tunnels are governed by various codes and standards, including the NFPA 101 Life Safety Code. These codes specify the minimum illumination levels, uniformity requirements, and backup power requirements for emergency lighting systems. Firstly, emergency lighting systems must provide sufficient illumination to allow people to safely evacuate the tunnel. The minimum illumination level is typically specified as 1-foot candle, or 10.8 lux, measured at floor level along the path of egress. Secondly, the illumination must be uniform to avoid shadows and glare. Uniformity is typically specified as a ratio of the minimum illumination level to the average illumination level. Thirdly, emergency lighting systems must be powered by a reliable backup power source such as batteries or a generator. The backup power source must be capable of providing power to the emergency lights for a minimum of 90 minutes, as required by the Life Safety Code. Fourthly, emergency lighting fixtures must be located in strategic locations throughout the tunnel to provide adequate illumination along the path of egress. The fixtures should be spaced to provide uniform illumination and avoid shadows. Fifthly, emergency lighting fixtures must be clearly identified with signage to indicate their location. The signage should be visible from a distance and should be illuminated to ensure that it is visible during a power outage. Sixthly, emergency lighting systems must be tested regularly to ensure that they are functioning properly. The testing should include a visual inspection of the fixtures and a functional test of the backup power source. Seventhly, the Life Safety Code also requires that emergency lighting systems be maintained in good working order. This includes replacing burnt-out lamps promptly and cleaning the fixtures to remove dust and debris. Eighthly, the Life Safety Code also addresses the use of exit signs in tunnels. Exit signs must be located at all exits from the tunnel and must be clearly visible from a distance. Ninthly, the Life Safety Code also requires that exit signs be illuminated to ensure that they are visible during a power outage. Exit signs can be illuminated internally or externally. Tenthly, emergency lighting systems play a vital role in ensuring the safety of individuals in tunnels during emergency situations. These systems must be designed, installed, and maintained in accordance with applicable codes and standards to ensure that they function properly when needed. Consider the potential for vandalism when selecting lighting fixtures. Vandal-resistant fixtures are available that can withstand tampering and abuse. These fixtures typically have tamper-proof hardware and durable construction. When selecting vandal-resistant fixtures, it is important to consider the level of protection required. Some fixtures are designed to withstand minor vandalism, while others are designed to withstand more severe abuse. Also, consider the ease of maintenance when selecting lighting fixtures. Fixtures that are easy to maintain can save time and money over the life of the lighting system. Consider factors such as the accessibility of the lamps and ballasts, the ease of cleaning, and the availability of replacement parts. Also consider the life cycle cost of the lighting system. The life cycle cost includes the initial cost of the fixtures, the cost of installation, the cost of energy, and the cost of maintenance. When comparing different lighting systems, it is important to consider the life cycle cost to determine the most cost-effective option. Tunnels with curves or changes in elevation may require special lighting considerations. Curves can create shadows and reduce visibility, while changes in elevation can create trip hazards. The lighting system should be designed to address these challenges and provide adequate illumination throughout the tunnel. Remote monitoring systems can be used to monitor the performance of the lighting system remotely. These systems can provide real-time data on the status of the fixtures, the energy consumption, and the operating temperature. Remote monitoring systems can also be used to send alerts when maintenance is required. The selection of lighting fixtures for a tunnel is a complex process that requires careful consideration of various factors. By considering these factors, you can select fixtures that will provide safe, efficient, and reliable illumination for the tunnel environment.